You're lying in bed at 2 a.m. You pick up your phone, habit, and for half a second you forget. Then you remember. The message you won't send, the number you won't call. And then it hits. A physical sensation, dead center in your chest, pressing down like something heavy was set there, and no one told it to leave. You've probably called that feeling heartbreak. But here's the question almost nobody asks. Why does losing a person feel the same as breaking a bone? In 2011, psychologist Ethan Kross at the University of Michigan ran an experiment that should have broken the internet before the internet was equipped for it. He recruited 40 people, all of whom had been through an unwanted romantic breakup in the past 6 months. He placed each one in an fMRI machine and showed them a photograph of the person who left them. Then he applied a thermal probe to their arm. Not enough to burn, just enough to hurt. He scanned what happened in both scenarios. The result was not what anyone predicted. When subjects looked at the photo and thought about being rejected, the regions of the brain that activated were not the ones associated with emotional processing or memory. They were the secondary somatosensory cortex and the dorsal posterior insula, the same neural machinery that had just processed the physical heat on their skin. The brain, at the level of raw sensation, could not tell the difference between a hot probe and a photo of a lost love. Social rejection, Kross's team reported in the Proceedings of the National Academy of Sciences, shares somatosensory representations with physical pain, which is a very clinical way of saying, your broken heart is not a metaphor. It is a biological event, a real one. So why would evolution build a system this brutal? To answer that, you have to go back much further than the 21st century. Further, in fact, than recorded history. You have to go back to a time when losing your person wasn't just painful, it was lethal. For most of human evolutionary history, you didn't survive alone. Group living wasn't a lifestyle preference. It was the mechanism by which Homo sapiens stayed alive. Shelter, hunting coordination, care during illness, protection from predators, all of it required people. Neuroscientist Naomi Eisenberger at UCLA, who has spent 2 decades mapping the overlap between social and physical pain, frames it this way. Our ancestors needed a threat detection system for social loss as powerful as the one they had for physical injury, because socially, the threats were equivalent. Get rejected from the group, and you were exposed. The brain's solution was elegant in the way that only evolution is. It recycled existing pain hardware. It didn't build a new system to process social loss. It drafted the same circuitry that signals a torn muscle or a burned hand. That's why when you lose someone, your dorsal anterior cingulate cortex, the region associated with the unpleasantness, the awfulness of physical pain, fires with the same intensity as if your body had been damaged. In a 2003 landmark study published in Science, Eisenberger and colleagues at UCLA had participants play a virtual ball-tossing game called cyberball inside an fMRI scanner. When the other players, secretly just a computer, stopped passing the ball, started excluding the real participant, the anterior cingulate cortex lit up. It correlated directly with how distressed the person said they felt. Being left out of a cartoon ball game triggered the same neural alarm as physical injury. If that feels slightly absurd, that's the point. Here's the counterintuitive part, and it goes deeper than the brain. Most people assume the pain of heartbreak is purely psychological, a mental wound, grief dressed up in metaphor. The data says otherwise. Heartbreak reaches into the body, surgically, and starts dismantling it. The condition is called Takotsubo cardiomyopathy, named after a Japanese octopus pot, because the stressed left ventricle balloons into that shape during the episode. It's better known as broken heart syndrome. It presents identically to a heart attack, chest pain, shortness of breath, elevated cardiac biomarkers, abnormal ECG readings. Emergency physicians can't tell the difference without imaging, and it's triggered not by blocked arteries, but by a surge of stress hormones, cortisol, adrenaline, released during acute emotional loss. Grief, divorce, bereavement. In a 2025 analysis published in the Journal of the American Heart Association, a team led by M. Reza Movahed at the University of Arizona examined nearly 200,000 U.S. patients diagnosed with Takotsubo cardiomyopathy between 2016 and 2020. The in-hospital death rate was 6.5%. Men who developed the condition died at a rate of 11.2%. You can, in fact, die of a broken heart. The research says approximately 1 in 15 people who are hospitalized for it don't leave. But none of this, not the fMRI scans, not the cardiac data, is the oldest part of the story. In the late 1970s, neuroscientist Jock Panksepp at Bowling Green State University was noticing something strange about opiates. He knew they dulled physical pain, but he also knew that opioid addicts disproportionately came from backgrounds marked by disrupted attachment, absent parents, fractured families, early social loss. He began to wonder if the drug wasn't filling a chemical void that relationships were supposed to fill. He tested it on puppies. He separated them from their litters, social isolation at its most primal, and recorded their distress vocalizations. Then he administered tiny doses of morphine. The crying stopped. The agitation ceased. The opiates didn't just ease physical suffering. They appeared to be patching something the absence of attachment had torn open. What Panksepp had found, and spent the rest of his career mapping across mammals, was what he called the brain opioid theory of social attachment. The same chemical system that makes physical pain bearable, the endogenous opioid system, turns out to be the same system that makes social bonds feel good. When you're with people you love, your brain is quietly bathed in its own natural opioids. When they leave, or when you lose them, you experience what is, neurochemically, a withdrawal state. The low opioid condition of social separation is what drives the frantic urgency to reconnect. Heartbreak, at its deepest biological level, is withdrawal from a drug your own brain makes, that your relationships supply. This system is not uniquely human. It runs through all social mammals. The puppy crying in the corner, the infant monkey clinging, the 300-million-year-old scaffolding of every attachment you will ever form. You didn't inherit heartbreak from your culture, or your parents, or the poets who wrote about it. You inherited it from something far older than language. So when you're lying in that bed at 2 a.m., chest pressed down by invisible weight, here's what's actually happening. Your ancient threat detection system has identified a social loss. Your pain circuitry has registered it as damage. Your opioid system is running a deficit it's trying to fix. Every instinct you have is 300 million years old and perfectly calibrated to tell you that what you lost mattered. The system works. It just wasn't designed for the world where the person you lost is still alive, 3 kilometers away, not picking up their phone. If this connected with you, the biology, the evolutionary weight of it, hit like, subscribe, and tell me in the comments. Do you think knowing why it hurts actually makes it hurt less? I'm genuinely curious.